Name the type of triangle PQR found by the points P, Q and R to be those. So first thing is, what is that we have been given? We have been given 3 points and they form some triangle. The question is what kind of triangle it is. It can be a scalene triangle, an equilateral triangle, isosceles triangle. It can be anything. A right angle triangle, isosceles right angle triangle. It can be anything. So we have to figure it out. How will we do that? By finding the lengths. We can find the angles also, but we don't have that in our syllabus. So first thing is we'll find the lengths using, of course, distance formula. So wherein we have x2 minus x1 the whole square plus y2 minus y1 the whole square to the power of half. So we have, first thing is we'll find PQ, which is root 2 minus of minus root 2 the whole square actually, okay, plus same thing again, close the brackets. If you guys are confused with the brackets, let me change the color so that it becomes obvious. Okay, does it make sense? And now on to root 2 plus root 2 is 2 root 2 and there are 2 of them. So we have 2 times of 2 root 2 the whole square. Close the bracket. So this is basically 2 into 2 square into to the power of half. Root 2 square to the power of half. So this root and square gets cancelled. Okay, I need to change the color. So root and square gets cancelled and we have 2 into 2, 4, 4, 8, 16. Square root of 16, which is nothing but 4 unit. That's a good number. Then we have QR, which again is, I'll use different brackets. Now I have to figure out what should I do with these values. Minus root 2 minus of minus root 6. Minus root 2 minus of minus root of 6 the whole square. Okay guys, I'll use square brackets. It will help you guys differentiate it. Then we have plus, this is minus root 2, or I'll take plus root of 6 and other end I'll take minus plus root of 6 minus root 2 the whole square, and this is square root of this. And we have over here, what formula are we looking at? We have to make use of a minus b the whole square in both the cases. So a square, yeah, we have to use a minus b the whole square. A square plus b square minus 2ab. Okay, so this would be equal to, I'll use something called as flower brackets. Okay, so we're looking at plus root of 6. Let me kind of help you guys out a bit more. This is plus root of 6 minus root of 2 the whole square plus, but the same thing, root of 6 minus root of 2 the whole square. How come it's the same thing? This would be plus actually, sorry, this is plus, my bad. Root 6 minus of minus root 2, so that would be plus. So we need the plus formula also, so I can do this. In the same formula, we have both the formula written and mathematically this is correct. Okay guys, so this is plus to the power of half. Okay, now we will expand it. This is an extra step, you need not write this. So a square plus b square minus 2ab, and again we have a square plus b square plus 2ab to the power of half. So plus and minus getting cancelled. We have root 10 square, root 10 square, root 10 square, root 10 square. And so we have 8 plus 8, that is 16 to the power of half. That is square root of 16, which is equal to 4 unit. Okay. So yeah, we have two sides to be equal. One more side, let's see that. Might be an equilateral triangle, who knows. And we have PR. So we have root 2 and minus root of 6. So we have PR, right, which is root 2 minus of minus, so root 6 the whole square plus root 6 the whole square, plus again we have 2 and root 6, so root 6 minus root 2 the whole square. This calculation we have already done, right, in the previous previous set of numbers itself. This is root of 2. Let me kind of, okay, so this calculation we already done it. It's the same thing, right? You can see that it's the same thing. The numbers have been flip-flopped a bit over here, and here it is root 6 minus root 2, same thing over here. End of it, you will get what? You will get 4 unit. So what is the conclusion? Since all the sides are equal, it's an equilateral triangle. It's an equilateral triangle. That's it. That's your type of triangle. Okay, so you can pause and have a look at the answer. Oh yeah, let me simulate it and show it to you guys. I don't have root value, by the way. So, I mean, I can't enter root values over here. I'll make use of the approximate value. So we have root 2 and root 2. I have written the values root 2, minus root 2, root 2, minus root 6, minus plus root 6. I've written these values. And root 2 value is 1.414 approximately. Root 6 value is 2.5. So I have it over here. Root 6 is 2.5 approximately. Okay, so we have 1.414 and again 1.414. Then we have minus 1.414 and minus 1.414. And then we have minus 2.5 and 2.5. And that is unit. Okay, it doesn't look like an equilateral triangle because it's kind of pulled apart. Let me kind of squish it. Right now, does it look like a square? Almost a square, is it not? And now we can see that this structure is an equilateral triangle. Okay, it might not be exact because of the values, and I might have not done this right. Yeah, now it looks okay. Do you think they are looking like a square? Anyways, you can clearly see that all the side lengths are approximately equal. Of course, definitely we can tell by showing the calculations that we can be sure that it's an equilateral triangle. And we have shown that. Okay, you can pause now and have a look at the answer.